Hello, and welcome to this OpenTopography video. My name is Chelsea Scott, and in this video, I'm going to show you several examples of contour lines and discuss what we can learn about the shape of the landscape. So to get started, if you haven't yet watched our earlier video on contour lines, I recommend you watch this. You can find this on YouTube. And this video discusses what contour lines are at a more basic level than I'll discuss today, and also how to generate them on OpenTopography. But once you watch that, please come back to this video. All right, so I'm now going to show you 3 examples of contour lines. Our first example is shown here, and we are in southwestern Colorado. And so here we have a map where I've plotted the topographic hillshade along with colored elevation, where blue is the lower elevation and brown to white are the higher elevations. And the contour lines are then shown in blue, and they are plotted with a 25-meter contour interval. So this means that the distance between each contour line is 25 meters. The height difference between each contour line is 25 meters. So here I've highlighted several features of interest that we can see in the topography from the contour lines. So here first we see these 2 local topographic highs, one here and one here, and these are shown in the contour line as closed circles. And we know they're topographic highs and not lows because they're the white color here, which, as we can see here on the scale, is that top elevation. Here we can see a river. You can see the shape of the river in the topographic hillshade. And then within contour lines, we can see the rule of V's, where within the stream, we see this distinct V shape, and the center of the V is pointing uphill. And then here we have a saddle point. So this indicates both a local topographic high and minimum, depending on your direction of travel. So if we're going from peak to peak, this point here is going to be a topographic low. But if we're traveling in this direction, up the stream or river, and then down the opposite stream or river, this area is a topographic high. All right, so in the next slide, we're going to look at the same area, but with topographic profiles. So here we're looking across those streams from the A to A prime, A to A prime, and this red colors shows the elevation plotted here versus distance. So you can see here at the center point, which is here, we reach a local topographic maximum. And now in the opposite direction, we have B to B prime, and that's shown here. And we see the 2 local topographic highs representing the mountain peaks. And then we see a fairly large flat area here in the center, and that represents this area. So just to restate, here we're looking at a saddle point, which can be both a topographic high and a topographic low. All right, next example is we are looking at the Letchworth State Park in New York, and this is commonly called the Grand Canyon of the East. And here is a picture of what it looks like, so you can see that structure of the canyon. Here are the contour lines. They are plotted with a 10-meter interval, and the elevation is shown here from 200 to 390 meters. Now we can learn a lot about the structure of the canyon from the topographic contours. So here we can see that the contour lines are very close. So there's not that much distance between each blue line. And here they're fairly close, but maybe not quite as close as on this side of the canyon. And that is in stark contrast to this side, where we see a much more open canyon. And we can see that by the much larger distances between the topographic contour lines. And we can then look at topographic profiles for the same area. So the top plot is looking here from A to A prime, and we see relatively steep canyon walls and with the steeper side on the left here, which corresponds to this side. Here on the bottom shows B to B prime, and I stretched it to be approximately the same horizontal or distance scale as the top. And we can see a much more open canyon, again, consistent with the contour lines. All right, and our last example is also in upstate New York. Here we are looking at Drumlins, and they are plotted with a 5-meter contour interval. And so drumlins are formed when glaciers move over an area and they rework the glacier till. And so here, each of these long, skinny features, this is an example of a drumlin. Here is another drumlin. And we can then also see them in the topographic map, where we see that these topographic contours really highlight the elongated shape of the drumlin and also the asymmetry. So here we see that this drumlin is very long in this direction, in the north-south direction. It actually indicates to the direction of the glacier movement is going to be in either the north or south direction. And then in more detail, if we look, we see very close contour lines here. So this is going to be a very steep change in the topography. And then we see much more gentle slope here, so a larger distance between the contour lines. Let's look at this again in the topographic profile. So here we're looking at this area here along this long drumlin from A to A prime. And this shows again elevation versus distance. And we see this very asymmetric shape of the drumlin with a steep topography here, which is going to be associated with those very close contour lines, and then much more gentle topography here. And we can actually use this shape of the drumlin to infer the direction of the glacier. So here is a cartoon from the U.S. National Park Service looking in cross-section view, and it shows that the glaciers that formed this drumlin are going to move from the steeper side to the less steep side. So we know here that the glacier moved from the north to the south based on the shape of the drumlin. Thanks for watching.